Yeah. I was talking yesterday about, like, have you ever seen, like, dolphin teeth? They're like killing machines. They really are. That's like a goose. Have you ever seen a goose's teeth? Hold on. Have you never seen a goose's teeth?
I have never been close enough to
But obviously you've seen a goose, right? Like, yeah. Hold on. So first of all, hold on. Dolphin teeth. So like dolphin teeth are like that, kind of, Yeah, they can be. They're to tear apart stuff, right? Goose teeth.
Yo. What the heck?
Look,
Why does it look like that?
I don't know. I have no idea.
It looks like that devil.
It does. It really does.
What the heck?
A lot of people discovered what goose teeth looked like after that video game came out, Untitled Goose Game. You never heard of Untitled Goose Game? It's a game that they've released on PC and for the Nintendo Switch, and it's basically like, it's a very soft game with like piano music, and you're playing a goose, and you have a piece of paper with a bunch of objectives on it. Sneak into the garden, steal the guy's keys, put the rake in the lake, like stuff like that, and you just have to do it very sneakily. It's called Untitled Goose Game. Anyway, whatever. Go back to this. We're going to talk about dolphins. So I am going to eventually post something before the end of today for you guys to do over the course of the rest of the week. It's just something very short and simple for Prob Stat. But obviously, we're coming up to this week off, and we have a lot of assessments in there. You guys had that quizzes assessment. One of my plans for this week that I wanted to do was I wanted to throw out and I'm going to put this in quotes, a makeup quizzes, so to speak, because I wanted to give, and I've told several people this, I wanted to give people an opportunity to, if you wanted to replace the lowest minor assessment grade that you have, the what? Yeah. So, for example, you do the makeup, whatever grade you get on that. As long as it's better than your worst one, I'll replace the worst one. And then because obviously we're coming up at the end of the marking period, and I just want to make sure things are taken care of before the last week of the marking period, which of course is the 9th to the 13th. Fun stuff. All the teachers, we got a giant spreadsheet sent to us from the principal, and it was a spreadsheet of every single student who had a failing grade in school. And it was like listed by teacher and by subject. And he was just like, here you go, guys. Make sure you're taking care of these. And we're like, okay. Like, we know we're teachers. But anyway, back to me. I want to talk about dolphins. I've mentioned dolphins before in the past, like dolphin therapy, but I wanted to go into a lot more detail about it because we're going to be doing something a bit more detailed with it. This whole unit that we have just recently been covering has been on graphical displays. We've been talking about histograms and bar charts and pie charts and all of that fun stuff in between. And this is no different. There's going to be some charts. There's going to be some graphs that we're eventually going to get out of this. But I want to run a simulation on dolphin therapy. Let me give you the details. Dolphin therapy basically came down to this. This guy decided, okay, does swimming with dolphins improve your mental health? And he decided to run an experiment. So he got 30 people who were known to, or volunteers, I should say, who were known to suffer from some kind of mental health affliction. And he had them all evaluated by a psychologist beforehand so that they had a baseline of comparison. And then he took the 30 people and he split them up randomly into group A, swimming with dolphins, and group B, not swimming with dolphins. And he took all 30 of them down in a Caribbean vacation. So they all got to go on a Caribbean vacation. But the 15 of them who were in group A, they got to swim with dolphins during that vacation. And the other 15, oh no, my coffee. The other 15 did not get to swim with dolphins. And here were the results. Now, I'm eventually going to put this into our notes, so don't worry about it right now. But you were either in the dolphin group or the no dolphin group. What do you mean?
They definitely knew that they didn't get to do that.
Yes, of course, but you still get to go on a Caribbean vacation, I know. out of the 15 that were in the dolphin group, after they got back from vacation, they found out that after they got reevaluated, 10 of them, their mental health improved. But for the people who did not swim with the dolphins, only 3 of them improved. So this begs the question, does dolphin therapy work? I mean, you brought up a good point, though. You would have been mad if you didn't get to swim with the dolphins. You know, that's a possibility. That is definitely a possibility. Barring that, is this evidence to show that dolphin therapy possibly could work? Or were there way more people who their mental health improved after swimming with dolphins? Yeah, of course, yeah. But there's a kind of a weird caveat twist to this whole thing. Think of a coin. Think of a coin, like a penny. You flip a coin 100 times. How many tails do you expect to get?
How many tails you said?
Yeah. Exactly. Yeah, you would expect that. Now, if I flipped the coin 100 times and I got 52 tails, would you think that there was anything wrong? Why not? But if I got 52 tails, I didn't get 50-50. I got 52 tails. Is there something wrong? No. Logically, I know what you're thinking. It's like if I get 52 tails, you're like, no, that could happen. Out of randomness, that could just purely happen. And there's nothing wrong with that. But if I flip that coin 100 times, and let's say I got 90 tails, 90. Now there's something wrong. Now you got to figure out maybe it's the coin, maybe it's the guy flipping it. I don't know, but there's something wrong now. See, the thing is, there are certain things that we can get through random chance that we think, yeah, there's nothing wrong with that. That could happen. That could totally happen through random chance. And there are some things that happen through random chance that we're like, yeah, no, something's going on here. Something's rigged. So I'm going to restate the question, but with a little extra. Does this table show that dolphin therapy works, or could results like this happen by random chance? Well, that's what we're going to try and figure out. That's what we're going to try and figure out. That's what we're going to try and investigate today. Does dolphin therapy actually work? Does swimming with dolphins actually improve your mental health? Or are results like this just the result of random chance? Because if it's just the result of random chance, then I'm sorry, we can't definitively say that dolphin therapy works. But if it's not the result of random chance, then we have something. We have something that we got to share with the world. Go swim with dolphins. I think they're killing machines, though. I'm not really sure. Do dolphins eat meat?
It's a chicken.
They eat meat. Yeah, they're like carnivores, though.
Yeah. We swim with dolphins in Jamaica.
Nice.
I mean, I did it, but my grandma did. I was too scared.
I'm sorry.
I thought it was gonna be.
No, they don't.
I was too scared.
Mhm.
They don't.
Well, lions don't bite until they're hungry.
There was a lot of them.
It's true, yes.
There was
Okay.
a lot of them wanted to- I wouldn't do it.
Okay, so what I'm going to ask for 2 things. Yes, I am going to ask for those notebooks to be out and open. But we are going to run a random simulation, so I am also going to ask for those Chromebooks to be out and open. Both. I want both at the same time. Yes. Do. What do we got here? Oh, man. I've gotten so many emails with kids moving to virtual. Yeah. So many kids moving to virtual.
Real quick.
Yeah.
Only go back a full 5 days. Virtual still an option.
I believe so. But don't quote me on that because I really don't know.
Imagine. Most of the kids are going virtual.
I know. Especially when they know, like, oh man, there's gonna be like 30 people in the room.
I'm out of here.
Exactly.
That's good.
But yeah, like I said, when when we combine classes, prop stat should be fine because then there'll only be 6 total in the class, maybe 7. It's not even going to be an issue. At least I hope it
One
won't.
of my classes is gonna have like 25 people.
Exactly. That's what I'm saying, right?
Literally like 25 people, maybe even more.
Let's.
My classes have like max 10 people.
Mhm.
Yeah,
Dolphin
I
therapy.
think it's like my English class or something. It's gonna have like 25 people.
Oh, it's a senior in English class too.
Yeah.
Like you guys need that to graduate.
Exactly.
Dolphin. No dolphin. Making this chart. Improve. No improve. I just want to make sure we have this written down. Oh yeah. This is notes. Notes. Oh no, nowhere just yet. We are going to use the calculator, but we'll get there. Yeah, we'll get there because we're going to need the calculator to run a certain random simulation a little bit, and you guys are going to do it for me. I'm actually going to combine your results with yesterday's class because there's only 2 of you. But we'll get there. Anyway, so like I said, there were 15 people in the Dolphin group. And there were 15 people in the no Dolphin group. 13 total people, their health improved. 17 total people, their health did not improve. And there were 30 people overall in the experiment. And the question that I am asking, does Dolphin therapy work? Question mark. Or is this the result of random chance? Does Dolphin therapy work? Or is this the result of random chance? Because like I said, if this is the result of random chance, then we have evidence to show that Dolphin therapy doesn't work the way that they think it does. But if we show that, well, no, this could not happen by random chance. There's no way that many people would have improved swimming with dolphins if this was the result of random chance. Nah.
That's fair.
Yeah. Oh, by the way, I want to add a little extra statement here. This table, I ran out of room, so I'm just going to add it at the top. This table is called a two-way table. It's called a two-way table because of the 2 directions of data that they give you. You can see how many people were in each dolphin group, dolphin or no dolphin. That's one way of looking at it. Or you can look at it from their mental health improving or not improving. That's the second way of looking at it. They also call this a contingency table. They also call it, I'll zoom in on that. That's, contingency. Contigency. They also call it a contingency table. I just want you to know that's just vocabulary, just so you know. They call it a two-way table because of the 2 ways you can look at it. They call it a contingency table. Just one of those vocabulary things. So here's what we have to do. When you flip a coin, you make an assumption. When you flip a coin, the assumption that you make is that the chance of getting heads or tails is 50-50. That's the assumption that you make. We have to make, if there's nothing going on with the coin. If there's absolutely nothing wrong with the coin, we're assuming 50-50. That is our baseline. We assume 50-50. We go from there. But for this dolphin therapy, we have to have a different baseline of comparison. If dolphin therapy doesn't do anything, if dolphin therapy doesn't help people's mental health, if it was just something that they did and it didn't improve or not improve their mental health, the question then becomes, well, how many people can we assume would have gotten better no matter what? Because they all went on a Caribbean vacation. Yay for them. Cool, cool beans. There were 13 people who improved no matter what. Let's just assume that for a moment. Let's just say that these 13 people, regardless of swimming with dolphins or not swimming with dolphins, let's just say that their mental health was going to improve just as a baseline. And that's actually what I'm going to write down here. That's the assumption that I'm going to make. I am going to assume, which I'm allowed to do. A lot of people say, no, I'm sorry, you're not allowed to assume. Well, in statistics, you are to an extent. You are to an extent. Assume that 13 out of 30 would have improved no matter what, regardless of dolphins. In statistics, if you want to show that dolphin therapy works, you have to first assume that it doesn't do anything. Assume that dolphin therapy doesn't do anything. Assume that there's nothing going on. In a court of law, I'm not saying that you guys are going to be put up for trial, but what is the assumption the court is supposed to make when you enter that courtroom?
Innocent until proven guilty.
You are innocent until proven guilty. There's nothing going on. You haven't done anything wrong. There's no shenanigans. We have to assume that there's nothing wrong with you, that there's nothing out of the ordinary, and then the evidence is presented. This is similar. This is very similar. When I say assume 13 out of 30 would have improved no matter what, that is assuming, oh no, my camera. That is assuming innocence until proven guilty. It's like, okay, let's just assume that you're innocent. Now let's build the case against you. You have to do that in a court of law. Oh man, did you guys see that? There was a mini series on TV a few years ago. They put it on Netflix, I think. It was called The People versus O.J. Simpson.
Oh, yeah.
Did you see that?
That was a good.
It really was. But the thing is, like, I was in elementary school when that actually went down. And the idea is, again, innocent until proven guilty. But there were a lot of people who went into the thing automatically assuming, no, he's guilty. Now let's build the case against him. Like,
See, at that point, it's kind of like,
I don't know. If the court of law is
and he
supposed.
still didn't get what's it called? He still didn't get convicted.
No, but he was found guilty later in a civil trial.
Yeah.
For something else, right?
No,
for the same thing. Yeah. And then, but he was found guilty again, like a couple decades later, because they organized a robbery to steal back some of his sports memorabilia. And he got convicted for that because he was a part of that robbery. So he is in jail. Yeah. Do you know the story behind O.J. Simpson? Cool. He wrote a book afterwards called If I Did It. Here's how I would have gotten it done or something like that. Who in the world does that? Anyway, back to this. Innocent until proven guilty. We're going to assume that 13 out of 30 would have improved no matter what. Let's just assume nothing's going on with dolphin therapy. Let's just assume dolphin therapy doesn't affect anything. Innocent until proven guilty. This is what we're going to do. We, and when I say we, I mean like you and me, are going to randomly simulate dolphin therapy. The whole point of randomly simulating dolphin therapy is to try and show, okay, can we replicate these results by random chance? Can we get 10 out of 15 improving their mental health just by randomness, pure randomness, which is why you guys have the Chromebooks open. You're going to be randomly simulating this in a little bit. So this is kind of reviewing random simulation from earlier in the year. Let's let 1 to 13 be improving. And let's let 14 to 30 being not improving. What we're going to do is we are going to randomly simulate numbers from 1 to 30, representing the 30 people. Now, we're assuming that there's a 13 out of 30 chance that people would have improved no matter what, which is what these first 13 numbers are going to represent. Okay, all right, if 13 out of 30 would have improved, let's let 1 to 13 be improving, and let's let the rest of them be not improving. And we are going to generate 15 random numbers from 1 to 30. Repeats are allowed. Because of percentages. And when I mean percentages, I mean that 13 out of 30. I'll zoom in on this in a moment. 13 out of 30 is a percentage that you can see there at the bottom. There we go. I'll zoom in a little bit. Move that up a little. There we go. Earlier in the year, I talked about when we were randomly simulating things, and I said, okay, well, are we allowed to do repeats? Are we not allowed to do repeats? And what it comes down to is you are allowed to do repeats if you are dealing with percentages. And in this case, technically we are, because we're saying 13 out of 30 is representing a percentage. If each number represented a person, let's say, an actual person, then that would be different. But now we're dealing with percentages. But this is exactly what we're about to do. Now, in a little bit, I'm going to have to collect data from you. I have, how many data points do I have from yesterday? From yesterday, I got to unarchive that. Come on. Okay, L1, unarchive. Unarchive. Come on, you silly thing, you. There you go. Yesterday, I collected data. I collected 25 data points. I collected 25 data points from my class yesterday. I'm going to collect 15 more. Each of you are going to run 5 trials, and I'm going to run 5 trials as well on our graphing calculators. The thing is, we're going to have to seed our calculators. When you guys open up the calculators, when you open up the calculators on the Chromebook, if you want to do that now, confirm for me real quick. When you open it, does it spit out the phrase RAM cleared? Yeah. So open up that calculator. Open up that calculator on the Chromebooks, because if it says RAM cleared, then we are going to have to seed our calculator. And I'm going to seed my calculator as well. And we're going to do this together because, well, I want to make sure we all have different numbers. Now, the thing is, I'm going to use today's date. I'm going to suggest that you use your birthday. Use your birthday. So when you seed your calculator, I'm going to type in today's date. Today is the 27th. You can type in your birthday. I was born April 1st. Okay, 4/1, and then whatever year you were born. It still creeps me out that none of y'all were born in the 90s. Creeps. Anyway. There are teachers in this school that were born in the 90s. That creeps me out. Anyway, back to this. So what I'm going to do is I'm going to have to store this number. I'm going to have to store this number somewhere. STO in the bottom left of your calculator, just above the on button. If you hit STO, you get a little arrow key there. Make sure you're hitting that because we have to store that somewhere. We have to store that number in a RAND, R-A-N-D. We have to store it in RAND. You get that by doing this. You hit math. If you hit math, you come to this screen. Tab over to PRB, probability, PERB, and the first one is RAND. If you do that correctly and you hit enter right here, it should just say the number over again. But if you've done that correctly, then your calculator has successfully been seeded. You need to seed that calculator. Say again?
I don't want to do it.
Hmm? Hit math. Right, there you go. Tab over to it's technically Prob, P-R-O-B, because you got more functions on yours than mine. And then the first one is rand, the first one. And then hit enter again. There it is, you're done. It's seeded. It is successfully seeded. Now here's what you need to do. Hit math again. And we're going to go over to PRB. Now I'm going to actually run one trial for you. I'm going to run one trial for you. I'm going to go down to rand int. I'm going to show you how to run this. Now, when you guys hit rand int, does it go to like an extra screen?
Yeah, it says lower and then upper and then
Lower is 1,
yeah.
upper is 30.
And then base.
Exactly. For me, I just got to do this. Now, watch this for a second. I'm going to show you how to run one of these trials. I need you for a second. Go to my calculator. Go to my calculator.
Go to the
All right, so now hold on. Remember for a minute, 1 to 13 represents improving, 14 to 30 represents not improving. Now again, we are about to randomly simulate the 15 people, just the 15 people who would have gone into dolphin therapy. And we are trying to randomly simulate, okay, assuming that dolphin therapy doesn't do anything, how many of them would have improved versus not improved? This is trial number 1. Okay, hit enter. All right, that's a 5. That person would have improved. Do it again. 14, not improve. Keep going. Improve. Hold on. You're going to hold on. 28, 11. All right, keep going. 23, go ahead. 7, 12 would have improved. Keep going. 8 would have improved. 2 would have improved. Not improve. Improve. Not improve. Improve. All right, stop. That's all I need. You know why? How many tally marks do I have on that board? That's all I needed. Wait, do I have more than 15? Oh, yeah, 15. Sorry. This line in the middle is screwing me up. That was screwing me up a little. There we go. But it is 15. Yes. Now that's one trial. That's one trial. And the number that I would report is 9. 9 people improved. 9 people improved. That's the number that I would report from that one trial. Now, I want to start trial number 2. You don't have to reseed anything. If you want to start trial number 2, you do not have to reseed anything. You just simply hit enter one more time. Or not one more time, but a bunch more times. But I would say I'm going to start trial 2 here for improve, not improve. I would hit enter. Boom. 23. Boom. And then I would continue.
For lower upper, what'd you do?
1 to 30. So this is how you guys can do this. Now, that was one trial that you and I just did together. That was one trial. I want everybody to do 5 trials. 5 trials. And I want those numbers reported. We're going to add, and I'm going to complete my 5 trials. I'll do my 5 trials on my own. But I want those numbers to be added to yesterday's numbers. So let us do this random simulation. I'm going to go do mine as well. And take a sip of coffee. Oh. Yep. Okay. There we are. I'm going to keep my first trial on board. Continue trial. Okay. Do you get numbers? Cool. Can I have them? Yeah. I just need the 5 numbers for each trial for each the number of people that improved.
8 for the first one.
Yep.
6 for the second. 10 for the third. 7 for the fourth. And 9 for the seventh.
That's weird. I think yesterday, I think I had an 11. Yeah, we had 111 yesterday. That was weird. But most of those numbers, yeah, are going to be pretty consistent right there. There was one person in the chat. I don't know if they're going to join us. I'm looking at the person in the chat now. If they're going to join us, they can just put their numbers into the chat. This is creepy that I'm standing like this, you know? What? Oh, no. That's all you needed it for. Did you get numbers for me?
I have 1 more left.
But it died? Okay, that's okay. Give me the 4 that you got. Yeah.
Which one do you need? I?
Yes, just improved.
4?
Yep.
8, 11, 6, 13.
Oh, so you did do them all. You got 13 on the last one? Wow. Now that could happen. That could absolutely happen. It's unlikely to happen, but it happened. So let's just see what happens. Now, look what we got up here. I got all your numbers right here. Let me just double check in the chat because I don't know if the person's going to add theirs. Nope, they didn't want to add theirs. Okay. Let's just double check. But I have all these numbers kind of sitting in the chat. That's great. That's fantastic. This is all of our trials right here. Let's take a look. If you remember, second y equals, you don't have to do this. I just want you to see this. I'm going to show you the histogram of this whole thing. Here we go. Zoom 9. Chapow. Ooh, interesting. That is interesting. With the exception of your 13, which might be considered an outlier, but we could calculate that if need be. But that's a different story. With the exception of that, with the exception of the little outlier that we have going on there, look at the shape that I got. I'm going to draw this again. Hold on. It still kind of works. It's slightly skewed to the right, but for the most part, the shape of this distribution is what we call normal. The shape of this distribution is what we call normal. Now, there was a video that I had you guys that I posted into the Google stream, or not the Google stream, the Google Classroom, for you guys to watch this video on introduction to the normal distribution, because I'm going to be subtly introducing it through the next several class periods. This is one of those introductions right here. But this normal distribution is the bread and butter of statistics. This normal distribution is the bread and butter of statistics. It has everything to do with the fundamental theorem of statistics. It has everything to do with real life data and the way that it averages out. It's amazing. What we have here is a little bit of a normal distribution, which is what I expected to happen. Usually there's a spike somewhere, and everything kind of tails off to the right and tails off to the left. Let's write some stuff down. Hold on, because there's a lot more information that we kind of got to get from this. Okay. Actually, before I do that, let me do this. Check this out. I don't know if you knew you could do this. Do you know what the A stands for? Sort A? Look what it did to my table. What did it do?
Just sorted everything by number.
Yeah, sorted everything in order, like ascendingly is what they call it. Sort ascendingly, and then they got all these numbers. Now, we had 40 trials. How many times out of that 40 did we match dolphin therapy or better it? How many times out of our 40 trials did we hit 10 out of 15 or better? Is my question to you.
Say it one more time.
Out of our 40 trials, how many times did we match or better dolphin therapy's 10 out of 15? How many times? 5 times. Yes, 5 times out of 40. 5 times out of 40. So let me write some of this stuff down. Check this out. Hold on. Zoom out. What am I doing here? Out of 40 trials, we were able to match or better dolphin therapy five times. That's 5 out of 40, which is approximately, probably do this in my head, 0.125 or 12.5%. Out of 40 trials, we were able to match or better dolphin therapy 5 times. I'll erase some of this stuff up here. There we go. Yeah. Oh, if you need to plug the Chromebook in, you should do that before you leave. Just get a little charge there. So this begs the question, is dolphin therapy something that actually works, or are the results that they got just random chance? What we have just shown, believe it or not, with this 12.5% number, what we have just shown is that, well, perhaps it is the result of random chance. Let me show you what I mean. Because we simulated similar results 12.5% of the time, it appears that dolphin therapy could be the result of random chance. I have more to add to that, but I'm going to stop there for a moment. I have more to add, though. Because we simulated similar results 12.5% of the time, it appears that dolphin therapy could be the result of random chance. 12.5% of the time is common. It's very common. 12.5% of the time is 1 out of 8. 1 out of 8. Like, I don't have an 8-sided die on me. I don't have an 8-sided die on me, but look at this. I have a 6-sided die. What are the chances that I roll this die and it lands on a 4? 1 out of 6. Yeah, 1 out of 6, which is roughly 16.7%, right? 16.7%. That's not out of the ordinary. That's literally a roll of the die. You guys have played games with dice before. You know how likely or unlikely it is to get something like that. I've mentioned this before. Hold on. We talked a little bit about my presidential prediction video. Check this out. Show you something here. This 538.com, this guy, Nate Silver, he's an amazing statistician. Right now, he gives Trump roughly a 12% chance of winning. 12%. We just got 12.5% on dolphin therapy. 12.5% could happen. It happened last time. It happened in 2016. It happened in 2016. But my point being, though, going back to this, because we simulated results that were similar 12.5% of the time, it appears that dolphin therapy could be the result of random chance.
Did you predict to win the election?
4 years ago?
No,
Today. It's a little hazy because I'm going to say two things. You ready? Caveats. If I had to put money on it, if they said, listen, you got to put down $20 or $100 or whatever, you're going to, bet. If I had to bet, I would say Biden's going to win. Okay? But in my prediction video, there's no money on the line. I'm looking at the trends. I'm looking at what possibly could happen in the next week. I'm looking at the way that states are getting closer and closer. In my prediction video, I did predict that Trump was going to win by a slim margin. But honestly, if I had to put money on it, I would say Biden's going to win. So that's my caveat to the whole thing. I made a bold prediction. But in reality, it is bold, So we'll see what happens. Now, if we were going to say that dolphin therapy did work, for dolphin therapy to have evidence of working, we would need that percent below 5%. For dolphin therapy to have evidence of working, we would need that percent to be below 5%. 5% is this magical threshold where if you're going to do this random simulation that we just set up, if you were going to get, if you were going to have evidence to show, hey, maybe dolphin therapy does work, maybe dolphin therapy is not the result of random chance, then you would have to have that threshold below 5%. Part of the reason we talked about O.J. Simpson earlier on trial, during the trial, because you said you watched the miniseries, but I know it's probably been a few years. During the miniseries, they showed a lot of DNA evidence. Okay, they showed a lot of DNA evidence, and they showed, okay, well, Mr. Simpson's DNA appeared here. The chances that his DNA would appear in this location are like 1 out of several billion or something like that. And they had these mathematicians, statisticians come in, and the jury had no idea what was happening. The jury did not understand any of the mathematics behind it. They didn't understand any of the statistical analysis and, this 5% threshold and something like that. They didn't get it. And because they didn't get it, all of that evidence basically was meaningless. Do you know what happened less than 5 years after the trial, or roughly 5 or 6 years after the trial? CSI. 5 or 6 years after O.J. Simpson's trial, CSI became a show. And it was a direct result of people having interest in forensic science and being like, what are they even talking about? And now CSI, I don't know, are there still CSI shows on TV?
Yeah, I don't really watch CSI though, but yeah, there's some.
Okay. I grew up with the original CSI. Really great show. And then they did like CSI Miami, which was a parody of itself. And then they did CSI New York and then CSI Cyber. It was all sorts of weird stuff. But that's what got people really interested in forensic science in the first place, just this idea of the O.J. Simpson trial and being able to prove, well, is it the result of random chance or is it not? If it were to be the result of random chance, then you would get results greater than 5% like we did. But if you were trying to show that dolphin therapy couldn't be the result of random chance, maybe dolphin therapy has something to say for it, then you would need something below 5%. Yesterday, I want to show you something. You don't have to write this down, but I want you to see this. These are the results from yesterday. Yesterday, we got this. We only got 1 out of 25, which is 4%. And yesterday, it appears that dolphin therapy is not the result of random chance. That was our result from yesterday. Today, we ran more trials. and we added our results to theirs. And we added our results to theirs, and we got 12.5%. Now I'm saying it appears that dolphin therapy could be the result of random chance. I really want you to see this, though. Yesterday, we said that it's not the result of random chance. Then today, we said it is the result of random chance. Is what we did yesterday wrong? No, it's not. It's not. Because in statistics, it's very fluffy like that. You could run a simulation and you can get certain results, and you can run a different simulation, and you can get opposite results. It's so messed up. It's like, I don't know. Let me show you something. Here's a simulation. Check this out. Come on, load. Here you go, right here. Check this out. I just highlighted 3 polls from yesterday. 3 polls from yesterday. 3 different polling companies went out and collected information just on Pennsylvania. And look at the 3 results that they got. They got 3 different results. One of those results being plus Trump. 2 of those results being plus Biden. Are they wrong? No, they're not wrong. It's the result of random chance. Oh, math is weird. It definitely will be close. But the thing is, again, I could flip a coin 100 times, and I can get 52 heads. And then you can flip the coin 100 times and get 45 heads. I got 52, you got 45. I got over 50%, you got under 50%. But neither of us are wrong. Neither of us are wrong, because the true number is 50-50. We know the true number is 50-50. See, the thing is, when you're polling, that's basically what you're trying to do. You're running a simulation on a random sample, and some results are going to be above the true number, and some results are going to be below the true number. But we don't know what the true number is until election day. Yeah. We won't know what the true number is until election day, which is the purpose of my video on YouTube, doing the simulation. Or not the simulation, looking at 2016 and being like, well, look at 2016. In 2016, these are where the polls were. But this state flipped 5 percentage points in the other direction. In reality, was it wrong? No, it wasn't wrong. It was just the way that they collected their data. The way that they collected their data was wrong, in my opinion. In my opinion. Fun, weird stuff. Okay, couple more things. I'm actually not done with the notes yet. I'm not done with that yet. So, I'm so hyped. We got a week. I know, right? Everyone's exhausted. Everyone's so exhausted from the election. But you know why I'm hyped? Because to me, it honestly doesn't matter who wins. It doesn't matter. We're still going to have a country. We're still going to be alive. The sun will rise tomorrow. It'll be fine. Is it really going to change your day-to-day life? There you go. Exactly. But people, they look at the election as if it's life and death. Yeah. I know. But for me, it's like I'm just so hyped for the math. Anyway, that's me. I'm a dork. Anyway, we can only conclude using phrases. I know, right?
Well, we were in 8th grade, right?
Yes, you were. Yeah. We can only conclude using phrases like "it appears" or "evidence to suggest." We cannot make definitive claims. That's why people always talk about like a margin of error. An error, the margin of error is not a mistake. The margin of error is a window in which, listen, we think the true number's in this window. In fact, we're pretty confident that the true number's in this window, but there is a chance we could be wrong. That's what a margin of error is. The best course of action is to replicate dolphin therapy with real people. We were talking about jobs after high school and stuff like that, or jobs after college. There are people that get hired to do this kind of stuff. There are people that get hired to organize statistical experiments in order to determine whether or not certain therapies or drugs work. They do this kind of stuff. Like a drug company will just basically be like, okay, listen, we want to do a commercial using like this pill. We think it can help with people's emotional well-being, but we want to pair it with this. So here's what you're going to do. You're going to organize an experiment with people swimming with dolphins, and you're going to get a lot of pictures so we can put out commercials, and you're going to have like groups either taking the pill or not taking the pill, and we're going to see whether or not the pill can actually help with people. People get paid for that kind of stuff. It's ridiculous. It is. But the thing is, it's good paying jobs because companies need these statistics to back up their claims. Statistics is used way more often than any other math you'll ever take, is my point. All right, let's draw something. I got one more little page here. And then we'll be good. This whole...
Forever?
No. Don't break my heart. Come on. Anyway. One more little thing here. He's singing now. I might get copyrighted claimed on YouTube. This is the normal distribution. Oh, yeah, I want you to draw that. Do you know what a paranormal distribution is?
Negative.
Okay, hold on. This is a paranormal distribution right here. There you go. There's the normal on top, and there's the paranormal on bottom. There you go. But back to this. This is the normal distribution. I'm going to add a bunch of stuff to this picture, by the way. This is the normal distribution. This is one of the graphical displays that we're going to be focusing on. A lot of real life data, when graphed, show this bell-shaped curve. A lot of real-life data, when graphed, show this bell-shaped curve. It's symmetric and what we call unimodal. Unimodal just literally means it has one peak. But this is a very common statistical display. Histograms often show the shape. And when the histogram often shows the shape, it shows a lot more. For example, right down the middle, if you had something that was normally distributed, right down the middle would be your mean, your X-bar, your average, right down the middle. Then there are these equidistant distances from X-bar going up on the histogram. And at each of these points, you would have these weird kind of calculations. Now, I'm going to explain what these are in a moment. Just want to write these out. There we go. Let me zoom in on that. Zoom, 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 zoom. S is your standard deviation. S is the measure of spread. S shows you how spread out or how close together your data actually is. It shows like the average deviation from the mean. So like think of it this way, what is the, if you had to guess, what's the average IQ in the world, in America? Average IQ. Okay. Say again? Oh, it's like 100. Yeah. All right, let's do it. Like I won't do IQ. I won't do IQ. How about average adult male height? Average adult male height. Oh, I was gonna say like 5'10". Me too. You know about my best friend Derek. I'm sorry. I told you about my sister's high school yearbook. My sister, she graduated Southern in '89. In her yearbook, it says best remembered for being almost 5 feet tall. I know. I felt really bad.
What does that say? X plus 2 what?
Oh, there you go. It's x bar plus s, x bar plus 2s, x bar plus 3s. Basically, what it comes down to is this. Let's say that the average adult male height is 5'10". Okay, 5'10". And if this is 5'10", let's just pretend that the standard deviation is 2 inches, just 2 inches, which means that this would be 6 foot, this would be 6'2", this would be 6'4" on the histogram. I know, adult male heights. Yeah, stupid.
What's it called? Isn't I forget there's a name for that. I heard of it.
I got you.
I really don't remember. There's like a certain name for it. Like that type of. I've heard of it, and it's not what you said. I forget.
It may be exactly what I'm referring to. They just may be using different terminology.
It's fine.
You know, but going the opposite direction is the same thing. It's x bar minus s, x bar minus 2s, x bar minus 3s. So again, like I said, if you had, I'm just going to kind of point to this on the board for a little bit because I have to add a couple more things here. If this were 5'10", these are all the adult male. I'm specifying adult male because obviously, on average, females are not as tall. You know, I know. I apologize for bringing that up again. You know, but this is 5'10". And then if the standard deviation is 2, then this is 6 foot, 6'2", 6'4". Anybody above 6'4" is out of the ordinary. Anybody above 6'4" is extremely an outlier. Going the other way, 5'10", 5'8", 5'6", I'm somewhere in that range. 5'4", now I'm talking adult males. Have you ever seen a grown adult male under 5'4"? You haven't? I have.
Actually, I have.
Huh. If you are an adult male that is under 5'4", that is pretty extreme. That is considered very much an outlier.
I feel bad for you.
I know. But now, think about the majority of the population. The majority of the population. See, the thing is, if you're above 6'4", there's a decent chance, a better chance than, let's say, me, that you're playing in the NBA. A better chance, you know, than me. Derek is 6'8", but he'd never play in the NBA because he hates basketball. And he has bad knees. Here's the thing. If this is 5'10", and I go from -1 standard deviation to +1 standard deviation, so I'm going 5'8" to 6 foot. Think about all of the adult males in the world that are between 5'8" and 6 foot. There's a lot, right? I would say there's a lot. In fact, there are approximately 68%. 68% of the population would be between these two standard deviations. If you were to go 5'6" to 6'2", 5'6" to 6'2", that includes me now. This would be 95% of the population. And if you were to go 5'4", all the way up to 6'4", you have almost everybody. You don't have everybody. You don't have Derek. But you'd have 99.7% of that population. That is a very important rule that we're going to get into eventually. But this is called the 68, 95, 99.7 rule for the normal distribution. It's pretty crazy. I do know a couple of guys who are under 5'4". They have what they call Napoleon complexes. You know what I'm talking about? Yeah. It's just like they're short and they try to make up for it in other ways. So I'm like, all right, you be you, kind of thing. But then anybody above 6'4", like, who in this school actually is over 6'4"? Do you know anybody in this school? Yeah. What about over 6'4"? A few years ago, we had a bunch of people over 6'4".
I'm trying to think. There's definitely. Oh yeah, Richie Diamond.
Maybe.
He's 6'5".
Does he have like a beard?
No, a little bit.
Okay.
He's so tall.
Yeah, but I'm saying, like, and you look at, whoa, but he's not even an adult yet, right? Because boys stop growing at what, 21? Yeah, so he could be even taller.
Yeah.
That's out of the ordinary. Now, if he were at an NBA game and standing next to the players, you'd be like, oh, well, yeah, he's not really that tall, comparatively. But if you put him into the population of the world, that friend of yours is an outlier. In fact, anybody above 2 or under 2 standard deviations is considered to be what we call unusual. But we will get into those details next time. So the next time, I may see you on Friday or may talk to you on Friday for a minute, but the next time that I see you, maybe we'll still have a country. I don't know. That's a joke. Of course we'll still have a country. Come on. Anyway, I'm going to sign off because that's the bell. Join me on